So welcome everyone to Client 310. This is the case-off featuring the AppV sequencer. And I love doing these discussions, these case-off discussions, because they're all weird and wonderful problems that we have when we go out onto the field. And sequencing is generally a very easy activity. One of the things that I'm going to be delving into in this discussion, in this hour, is showing you a number of applications that we've actually had delivered to us from customers, problems that we had with when we were trying to sequence them, and how we basically took these steps to troubleshoot these issues and troubleshoot these sequenced applications. Out of interest, how many people here have actually sequenced an application using AppV? So there's quite a good little crowd here. Now, one thing I wanted to highlight in this session is this session is not an in-depth dive into the sequencer. I'm not going to go through all of the features and all of the items about the sequencer. And one of the reasons why I didn't want to do that is because it was delivered at TechEd North America. Now, at TechEd North America, a colleague of mine called Chris Green did a session called Sequencing Deep Dive, efficiently making your applications virtual. And it's up there on the internet. You can literally go up there to msteched.com 2010 North America, and it's VIR 320. And you can watch this. You know, it's freely there. What's the point of you guys coming to TechEd and seeing stuff that's freely on the internet? We wanted to give you stuff that was more interesting, more stuff that you probably will never see in your common day-to-day environment. So if you want a good overview of the sequencer, if you want a good understanding of the logic that goes on behind the sequencer, please review this session. It's absolutely fantastic. So what I wanted to cover off today is I wanted to cover off basically some of the pain points we've gone through with customers. And these are basically sequencing issues or sequencing challenges we've had. Now, there are a couple of items to highlight here. And these are basically some of the topics that are going to get brought up as we go along in this hour session. Some of it's going to be general basic knowledge. Other bits of this are going to be around missing files and unsupported subsystems that the sequencer can't handle. Other areas are going to be interaction with processes on the local platform. There's going to be some stuff around application compatibility using AppV. Some items around merging and overriding the file and registry. So when AppV instantiates its applications, how does that virtual application see the underlying operating system? And I also want to delve into some cases we've had around dynamic suite composition. And what dynamic suite composition is we're basically taking two separate virtualized applications and merging them into one virtual environment so they can both see each other. So this is probably the most important thing that I will say to everyone, is that almost every application can be sequenced. And I'm not joking in that respect. I sequence anything. If you want to get onto my laptop, and this is my day-to-day laptop, you have to be able to be sequenced. So I run Office virtually, both x86 and x64. All of my analysis tools I tend to run virtualized as well. Anything I download off the internet will always get sequenced and then put onto my laptop. And I like that because I like things being in their own isolated environment. But there are some things that I can't virtualize. There are certain subsystems that we can't take into account. So I can't do boot time services. So things like Live Sync, where I have all of my laptops syncing my documents everywhere, I don't virtualize. That runs a background service when that's taking place at startup time. Things like drivers, we can't virtualize drivers. So there are certain things that you have to be aware of when you do go through and sequence applications. And if there's one thing I would say to you is that sequencing is generally a very easy activity. It's very much a next finish task. And there's a lot of jokes around sequencing being a next finish task. But to be honest with you, it is. What I would say is the more complex and more challenging activity is the discovery phase. Sequencing is basically capturing a set of steps that you've already got predefined. So if it's installing an application, it's working through that installation. The hardest challenge is understanding the application, understanding where those install binaries are. How should I install it? What registry keys do I need to inject into this application? What files am I missing for this package? Where is my source media? These are the troubles that we actually get when we go to customers. How many people here have all of their source media for all of their applications? So it's quite a small answer actually going up there. How many people actually know how to install all of their applications in their estate? Basically, you've got recipes, documentation around it. So I think that was 3 hands in quite a large room of people. The other thing I tend to warn customers about when you are going through this discovery phase is, fine, we now understand our application, but we also need to understand how Windows works. So as I said, there are certain things that we can't sequence, one of them being drivers. But what I can do is I can look to extrapolate the drivers out of a package and deploy them separately. I can look at certain areas of the Windows platform that I know a driver registers or it installs to. So it's understanding Windows, understands where Windows stores items. And the next, the most important thing is understanding the sequencer. Now, when we sequence packages, when we sequence applications, we go through this task using the sequencer. And the sequencer has a predefined set of tasks and rules. And understanding some of those rules and understanding what it's trying to achieve would, again, help you be more successful with your packaging activity. So the first thing I wanted to quickly do is I'm just going to quickly bash through a quick install of Netmon using the sequencer, because I just really wanted to show the basic steps that we go through when we sequence an application. So here is my sequencing workstation, and essentially I've downloaded Netmon 3.4 to my local platform. I've just got the installer there on its desktop. And when I open the sequencer, it gives me 3 choices: create, edit, upgrade. It's quite simple. 3 simple buttons that you can work from straight away. And in this case, I'm just going to create a very simple package of Netmon. So I'm going to hit create, and then it's going to ask for some basic details. It's going to ask for the package name. So in this case, I'm just going to say Netmon 3.4. I'm going to put my comments sequenced by JZ, and then I'm going to hit next. At that point, it says, right, there's one big button you've got to choose from. That's begin monitoring. And when I select begin monitoring, it's going to ask me for a primary directory. Now, the primary directory is always an 8.3 folder on your mount point. In this case, my mount point is my Q drive. So I'm just going to specify an 8.3 file name, netmon.001, and I'm going to say OK. What happens at this very moment in time is that a sequencer basically wants to basically see what's going to take place next. Anything that tries to install any changes, any file system changes, any registry changes that take place from this point forward, I'm going to capture. So now I'm going to execute Netmon 3.4. I'm going to hit run. Yeah, we want to install the capture and the parse engine. So I'm just going to say yes to that. Hit next. Accept the terms and conditions. Please do, or read your EULAs. There's some important information in there. Hit next again. And then I'm going to just say a custom install. I want to basically install this Netmon package to that 8.3 folder name. By default, it goes to C program files. I don't want it to go to C program files. I want it to go to my Q drive 8.3 location. Hit OK to that. Hit next, and hit next again. And it just goes through and it installs the rest of the application. You know, in a couple of minutes' time, this will go through and it will say it's essentially finished, and I will launch the applications a couple of times, and then I will save the output off that file to my desktop platform. So whilst that's almost done, hit finish again. It kicks off another little phase. So this is a rather rapid install. And I just wanted to get that framework there so that everyone was on the same page. Essentially, sequencing is straightforward. I'm just following a set of steps. I'm just following my installation methodology that I've had for many, many years, but I'm making a few slight differences. I'm installing it to this Q drive, to this mount point. I'm installing it to this 8.3 folder name. So we'll just wait for this to finish off, and then I'll show you the output, show you the last few steps, and then we'll kick on to some of the horrible cases where Netmon is actually one of them. So it's a nice foundation for us to move on from. And Windows time is the best time ever. Ta-da. Right, fantastic. Once we've installed it, we can just run it a few times, just get rid of any run once conditions, potentially any customizations that we might want to have at the beginning. And then we hit stop monitoring. We go through, we just monitor what's being installed, we capture all of that out, and we start saving it all into the virtual file system and into the virtual registry. If we hit next, we come to the configure application stage, and this is basically where we're defining our exes that we want to launch from the virtual application. We can also define the name of the application, version number, and also the outputting OSD file name. We can also define things like file type associations and also the shortcuts, where these shortcuts are actually going to be placed onto my platform. When I hit next, we come to a phase of the sequencer called the launch applications phase. And this is basically trying for us to analyze the application to see what section of the application do we need to use to get this application up and running as quickly as possible. So if I just launch Netmon, what we essentially go through and do at this point in time is monitor all of the file IOs taking place to understand what parts of DLL, what part of an exe do I need to get this application up and running as quick as possible. Once we're done, we can hit next. And that will capture all of the blocks. We hit finish, and that's essentially a quick, dirty capture of Netmon in App V. At the output of that, we have a number of different properties. So this is our outputted properties page, tells us our package name. One thing you'll notice at the bottom here is we have a launch size. Now, when we launched Netmon in that launch applications wizard, we only needed 4.85 megs of the whole 57 megs of Netmon to get the application running as quick as possible. We have a deployments tab where we can actually set filters to what operating systems we want to deploy this application down to. We can see change history. So if we've updated this package at a future point in time, we can go back and review those changes. We can see files that we've actually captured from the virtual file system and on the Q drive. We can actually see and modify the registry as well. And last but not least, the virtual file system. So these are basically things that have installed to the C drive, but we map them back to the Q drive, and then these are the actual mappings that we look to achieve. Once we're happy with that application, we hit save. I'm just going to save this application to my desktop in a folder called Netmon. Hit save there. And what you see in that lovely little folder is our outputted files for an application. And we get a couple of things. We get a few OSD files. You can see OSD here at the end. The OSD files are basically how do we launch this application? What is it that we're trying to execute? How do we set this in? How do we set the environment? That's what's in the OSD file. The SFT file is our application binaries. It's our exes. It's our DLLs. It's our virtual registry. It's all within that SFT file. The SPRJ file is a project file that the sequencer uses to pull the application back into the sequencer and understand what the sequencer is required to do. And we have an XML manifest file. This XML manifest file is used in SCCM, and it's used in standalone deployments. And the XML manifest file basically has publishing information inside it. So where do the shortcuts need to get published to my desktop when I deploy it? Where do the shortcuts, or where do the file type associations, or what file type associations do I have for this application? And lastly, we get a set of icons. And those icons just make the start menu and desktop look pretty when you deploy it down to an end user. So that's our quick and dirty Netmon. So let's kick into some of the cases off. So this is the case of the missing file and subsystem. And it's going to be used in Netmon. And we've just quickly gone through Netmon, and that's pretty much what our customer did when they went and deployed Netmon. Yeah, so the Q drive is our virtual mount point. Whenever so the Q drive can be any drive that you want to have as your baseline in your organization. And what we basically do when we install to the Q drive is what we're trying to say is install as much of our file system, as much as the application, to that Q drive so we can mount it up quicker. So essentially we're not trying to enumerate the file system on the C drive. Now what the Q drive is there to do is, on my sequencer workstations configuration, is if my sequencer is Q, or has a Q drive that I install to, my client workstations that I deploy to, when it installs the AppV client to those client workstations, will ask to have a virtual file system set up. And that virtual file system, by default, in my environment, is a Q drive as well. The reason why we ask to keep these file systems the same, the one on the sequencer and also the one on the client, is that if we deploy an application an application may in its own binaries or may in its own configuration may have hard-coded paths to certain locations. So for example, SAP could install onto your platform and SAP may want a hard-coded path to a particular file structure. And by us maintaining the Q drive for the sequencer and the Q drive on the client machines means that we potentially won't have those issues or conflicts or problems with applications getting distributed out there. So this is the case of the missing file and subsystem. And essentially, the problem was the customer went through and they sequenced Netmon, a bit like what we just did a minute ago. But when they started Netmon, when it was delivered to a AppV client, an error occurred and a dialog box appeared. This was the error. This was the dialog box. So it basically came up with this error, failed to load the MPL scripts. And I actually have that package. If I just bring it over to our workstation. So what I'm going to do here, I'm just going to quickly run an elevated command prompt. And let's go to case off and just do a wham. So just to show you what I'm doing here, just so that we're all in tune. What I'm basically got is I've got the Netmon package that we created earlier. And I've deployed it to this client workstation. And this client workstation is running what we call standalone mode. It has no requirement for an AppV infrastructure. It requires no SCCM, it requires no AppV full infrastructure. And I've executed this command here. It's this sftmime add package command. And that command is basically saying, add package, call the package this name, and the package name can be anything you want. And what I want to do is I want to specify this manifest file. And the manifest file is the XML file we created at point of sequencing, which has all of the publication information. And publish that to my desktop, or publish that to my client computer, and specify this override URL to this SFT file. The override URL basically says we're going to intercept any calls for the SFT file for this application and point it to its binaries in a specific location. Once we do that, my Netmon icon appears on my desktop, and now I can now execute Netmon. And what you'll see in the bottom right-hand corner, that will stream down from my SFT file into my AppV cache. And as you can see, I get this lovely little error, failed to load MPL script. So what do we do at this moment in time? We have this error. It's as clear as day to us. We thought we sequenced it absolutely perfectly, but obviously not. So whenever we get errors or issues, one of our core tools from Microsoft is a tool called Process Monitor. Process Monitor allows us to analyze and look at the file system and registry items being touched when an application is starting up. It basically analyzes anything that's going on that base platform. And we use this tool to death internally. So it's not just you guys that will use this. This is Microsoft internal. We use Process Monitor to analyze application issues. And we've basically got a command that we tend to use, and it's this one. And this is us executing Process Monitor. And what we tend to use is a /external capture. Now, a /external capture allows us to interface Process Monitor with an AppV environment. At that point, I tend to use a no-connect command, which basically says, Procmon, I know you like to start up and get going straight away, but actually slow down, stop, wait for me to initiate your capture. And then what we can actually do is then say, save all of the files that we do capture into this PML file. So that's what we're going to do. We're going to fire that command off and then launch Procmon again, Netmon again. So here's our machine. I'm just going to close that down. And all I'm going to just do is find Process Monitor. I'm just going to run an external capture. I'm just going to say no connect as well. So there you go. There's Procmon started. It's now interfacing with the AppV environment. So if you don't do this external capture command, what happens? Well, essentially, Procmon can't interface with the AppV environment. And because the AppV environment is in its own isolated bubble, we can't see what's going on. We can't see what we're touching in the virtual registry or inside the virtual file system correctly. So by doing that external capture, it allows us to see inside the virtual registry and allows us to see in the virtual file system correctly. So if we do miss something out or we do have problems, we can see it in the correct fashion. I'm now going to start monitoring. and I'm going to run netmon. Boom. There you go. Failed to load the NPL script. So once you've done that, once you've actually captured the information that you want to analyze, we can now start to use netmon and start to filter down the information we want to see. So at this moment in time, I have 67,000 events that have taken place in that one little transaction. Now, I'm not going to spend all day looking at 67,000 events. I've got better things to do, including a party at 6:30 tonight. So, I really want to filter down this information as quick as possible. So we know a couple of things. We know when we launch netmon, we have this error that comes up. And one of the good things in Process Monitor is it gives us a whole list of filters. And there's lots of filters there. There's lots of filters about processes, what process is actually executing, filters on paths, filters on architectures, filters on operations. So in this scenario, we know that our process that is actually launching is netmon.exe. If we filter that filters things down now to 3,278 events showing. But that's still not great, is it? There's still quite a lot of information for us to trudge through and get our real answers going on. So what else would people suggest? What else in this room? And it could be anything. I've got a prize of a bottle of water that I'm willing to give away for the best suggestion. Pardon? Failed results, that's a good one. There's potentially a more apt one. Any other? NPL script. We got a really clear error that came up for us. Failed to load NPL script. And inside Procmon, we've got this thing called a path rule or a path filter. And what you can actually do is say, right, if something with such a name exists, tell me about it. So in this scenario, I want a path filter, but I don't know the full path for this. So I'm just going to say, do a filter that the path contains. And what I'm going to do is I'm going to do a filter on the path contains NPL and say add. And hit apply. So now we're really filtered down. Now we're just down to 44 results out of 67,000 that we had right at the very beginning. And straight away, I can see something. So what we actually see here is some path not found. And we have two paths not found that are really jumping out at me. One is for a path not found under C users, AST documents, network monitor, parser, sparser.mpl. And another one is under my app data local Microsoft Network Monitor. Now, remember what I said earlier on. It's really interesting to understand an application. And one of the things that we see here straight away is that there's these two files, these two NPL files that don't exist. But I mean, this is only half the story, right? Because as I'm installed it, these files may not have been there at all. So one of the things, again, we try to do internally whenever we do have a problem or do have an issue like this, is we try to do a procmon whilst installing the application. So if we go and open it, and here's one I created earlier for the Net1 install. And what I'm going to do is I'm bringing it in, and when you do filters in netmon, they don't reset. So you just be aware, these filters won't reset. And what we see here is we see a whole load of information, a whole ton of stuff. We've still got 6,472 events that are taking place. Now, I still don't know if that NPL file even existed or even created as netmon installs. I don't know whether this is just a red herring or not. So what I can then look to do, again, is I can go into my filters, and if this is an installation that's taking place, what do you think these NPL files would be doing? There would be some sort of create or write that would take place, right? So again, we have a filter in netmon, which is an operations filter. And if you're not too sure on what you want to actually search for, you can say an operation contains, and in this case, I'm actually going to say a write. Because it would be a write file. A write file would have taken place to the disk. And I'm going to apply that. And lo and behold, we have two entries. One under the parser and one under app data local. And so they did exist. They were created as I went through and installed netmon. But why did they not take place? What actually did go wrong? So remember what I said at the beginning. It's one thing to know your application. It's another thing to understand Windows. But there's another aspect you have to understand, and that's the sequencer. And inside the sequencer, when you go and you package an application up, we have certain rules that we look to apply. When we package an application, we go through a phase which was the monitoring phase. And we look to monitor anything that gets installed, any changes, any modifications that take place to the base operating system. Once we do that and we get to the end of our monitoring phase and we capture our package, we go through and parse all of this data. And what we try and do is we look to tokenize all of the application data that gets captured via the sequencer. We want to make this application data portable. So, for example, if there's a hard-coded name in the registry for my computer name, I want to strip that out. I want to put % computer name %. I want to variabilize this information so it can be used anywhere. Once we do that and we pass that data, we go through a stage called the excluder. And what the excluder does is it basically goes through and takes a number of known locations to the sequencer and says, you know what, this information is generally rubbish information. We don't want to capture that. Things like your internet cache and a number of other different areas on the sequencer. Once we go through this phase, we go through and we classify all of the data. And we classify it either into application data or user data. And once we've done that, we save the outputted SFT file. So with this in mind, what do you guys and ladies, think that's actually taking place at this moment in time? There are files being excluded. And if I pop back over to my sequencer, under Tools, Options, we have this tab. We have the Parse Items tab, and these are all the things that are going to get variabilized. And we also have this Exclusion tab. And underneath this Exclusion tab, there's App Data Local, and there's also my Documents location as well. So for me to be able to successfully sequence Netmon, I have to go ahead and remove out these two exclusion items, which will allow the sequencer to capture Netmon correctly. Now if I do that, and if I just shut down Netmon, what I hope to get is a working Netmon. And funnily enough, here's one I created earlier. I'm just going to wait for Netmon to shut down. And I'm going to execute Netmon. It's going to stream down. Hey, so we're a little bit further along. This is absolutely fantastic. So why don't I just go over and do a new capture just to show this isn't any tricks or anything, and hit start. Whoa. Oh, this isn't good fun. So none of my network adapters are bound to the Netmon driver. Maybe this is an issue with privileges, yeah? So let me just quickly go back. Run as admin. Yeah. New capture. Start. Why? Why is Netmon giving me this horrible error? Exactly. You have to understand your applications. And the sequencer doesn't capture drivers. We don't virtualize the driver stack. And inside Netmon, we have drivers. So drivers are an interesting point. There's a number of things that we don't capture when we sequence applications. Complus, DLL surrogates, boot time services, and drivers. But you can identify these components and deploy them separately to the platform. Netmon itself adds a network filter driver when you deploy it to a client machine. And with any drivers, they tend to do a couple of things. One is, if you understand Windows, Windows has this whole driver store. And under WinDir System32 drivers, we tend to dump the INF or .sys files into that location. Also, under HKey Local Machine System Current Control Set services, we tend to register any driver that gets deployed to the platform. So you can look to identify those drivers, separate them out from the package, and deploy them separately. So let's go back to my lovely little client machine. And if I just go to my network stack, under my adapters, properties, what we can see here is if I go to install and under services, what you normally see is a Netmon driver located here. Now you can look to deploy the driver out using something like dpinst or something from the driver framework. I've literally created a very quick script that will deploy the driver to my platform. Next time I go to my services, I can bind that to my actual network stack. Netmon driver is now bound to my network adapter. And now I can go ahead and see all the traffic, hopefully, that's taking place at TechEd. So at the bottom left-hand corner, we see the network stacks bound. If I go new capture, hit start. Right, we've got a working Netmon install. Everything's singing and dancing. We're capturing traffic off the network. So the whole point around this one, or more than anything to show to you guys, are Netmon has a number of different aspects to it. It has missing files. It also has unsupported subsystems. But you can look to identify those missing files, and you can look to identify the missing subsystems and either encapsulate them in the sequencer or deploy them manually to the platform using something like SCCM or another third-party ESD solution. So that was the case of of Netmon. And now I've gone on to the next one. This is the case of the missing PuTTY web link. And this was an interesting one. We basically had a customer that uses PuTTY all the time. Show of hands, how many people know what PuTTY is? Brilliant. It's nice and easy. It's a real nice and easy one. So PuTTY is essentially an SSH tool, and it's a really handy SSH freebie download. Loads of customers use it, and this one customer went ahead and they deployed PuTTY out there into their environment. The problem is that PuTTY's got several components when it installs. It's got a SSH tool, but it's also got a web component that goes into some of the instructions. And what this customer was seeing was when they launched the PuTTY website, it would immediately start and then shut down. Let's give you an example of that. So I've just deployed PuTTY to this machine. And when we launch PuTTY, we're going to see it stream into the cache, and it's going to execute and launch correctly. Now, the customer said that when they actually launched PuTTY, or when they basically launched the PuTTY web link, it would launch fine initially, and it would browse to that website that it's trying to get to. However, what they found was as they're browsing around and surfing the internet and going and reading some great blog articles, they basically had an issue with launching it. And if I go to PuTTY and then now launch PuTTY website, whoa, can you see that? It started and shut down. Let's get a little bit of zoom in action going on here. So let's, oh, not that one. PuTTY website, launch, shut down. Again, the same theory applies. Whenever you're looking at anything, or I generally say, process monitor is your best friend. And it's also understanding the application as well. So what I'm going to do is I'm going to fire procmon, again, into the environment with an external capture. I'll say no connect. Now remember, when you launch Process Monitor again, the filters are already applied from the last time you used procmon. So a good practice is just to reset those filters so you can get going again straight away with the correct issue. Now again, our website is open, so let's just close that down and reopen that up. And let's reproduce the issue. So we're going to say capture, and we're going to say PuTTY website. It's launched and it's shut down straight away. So once we have this, or once we have this information, it's good for us to know a bit about the application. And generally what I try to do, as I said before, is I installed it locally. Now in this situation, it was quite interesting. When you install it locally, that web link actually refers to a file on the base platform. It's a file called website.url. So again, using that same rule set that we had earlier, that same filtering rule, we can say, give me a path rule that contains website.url. And hit apply. And straight away, we can filter this information down. Remember, it's all about just understanding the application, what's it installing. And straight away, you can see this thing saying path not found. There's a file there on the Q drive called PuTTY, in a folder called PuTTY-R1, PuTTY website.url. And it's coming back with this path not found. So what's going on? What's the issue? What's the problem? So I come over to my trusty whiteboard now. So AppV is a great technology. It really, really is a sound technology to use, and it does some fantastic stuff. And one of the beauties around AppV is this thing around isolation. So isolation allows us to have multiple applications running side by side on our base platform. So just for example, here's our Win 7 machine, and I can have multiple applications running side by side from the same generation or same family. Now the problem is that these applications can see down to my base operating system. But one thing my base operating system can't do is it can't see up into the virtualized applications because it's isolated, it's sandboxed. We don't want that interaction to be taking place because we don't want to cause any potential issues or problems. So in this scenario, what was actually taking place was that IE was executing on the base platform. And when the website.url was being invoked, it was being invoked and trying to call itself into the open process for Internet Explorer, iExplore.exe. Because iExplore.exe has no access into this virtual environment because it's isolated, iExplore.exe couldn't get the website.url file and therefore failed, and therefore the application shut down immediately. So how did we solve this issue? Well, this one was actually quite a nice, easy one for us when we did come across it. Essentially, after we did the process analysis, we found out that in their OSD file, and the top one is the actual original OSD file, we found that actually the file name that they were trying to execute was the website.url file. And that was trying to invoke the injection into the current iExplore.exe process. What we ended up doing was we ended up modifying the OSD file to say invoke iExplore.exe and passing this parameter, which is this URL file, to execute. What happens at that point is this. So I'm just going to close down. So now we have our application open, our Internet Explorer browser open, and now we can go and find our website for PuTTY. And now when it executes, it launches. But now what happens is it launches in its own process. So iExplore.exe execute, and we just basically get another window open for PuTTY. So that was quite an interesting one because, as I say, it's all about understanding the isolation, all about understanding your virtualized applications and what they're calling in and what the issues potentially are around those applications being called in. The next issue I have is the case of the application compatibility. Now, who here thinks that AppV is an app compat tool? Oh, I like all of you guys. You're good. Oh, one over there. Okay. So AppV is not an app compat tool. AppV is app-to-app isolation technology. AppV, and I emphasize this, it is not an app compat tool, so please don't think it is. We had a situation where basically a tool was sequenced on XP, and the customer just wanted to basically pick that application up that they sequenced on XP and deliver it to their Windows 7 machines in their environment. And it was a really important application. It was this stock viewer application. So let me flip back over here. And there's this cool little tool, Stock Viewer. When it executed and tried to launch the application, it had some really weird results that came off the back of it. One is it took a little while to launch. The next, it would come up with this annoying prompt saying that you had to be an administrator to run this application, which it didn't used to do on XP. Once it was launched, it brought out a stock tool. And whenever a user went ahead and tried to click on the trends information, it gave this annoying error and gave us a lot of random, unhelpful hex values to really sort of wind up the end user. So as I say, the customer is really about wanting to make their lives as easy as possible. They've already sequenced this application XP. We just want it to work on Windows 7. Why is it not working on Windows 7? And what they ended up doing was they ended up installing the application on Win 7 and also understood that whenever they natively installed it on Windows 7, it had exactly the same problems. Now, in Windows 7, and also in previous versions of Windows, we have a tool called the Application Compatibility Toolkit. And part of that toolkit is a tool called the Standard User Analyzer. This is the Standard User Analyzer. And what it basically does is it looks to read in the application that's having problems or having problems working correctly on Windows 7 and tries to help you. It just tries to help you give you mitigating methodologies to make the application work correctly. So what I want to do is I don't want this application to run in an elevated fashion, so I'm just going to untick this. And I'm going to browse for my exe. And I've installed the application locally onto this machine. There's my stock viewer app, and there's my stock viewer exe. Once I've selected that application, selected that exe, I'm just going to fire off and launch it. And what the tool will do, the Standard User Analyzer tool will do, well, it will monitor this application launching. It will monitor all of the things it's trying to do. So again, we get our annoying prompt. We then go into our trends. We get our other annoying trending tool with this random hex value. But once I'm happy, once I've gone through and shown all the issues on the application, I can now close the application, and the analyzer will basically go through and show you issues that potentially you will have with that application on Windows 7. So we can start to see issues around the file system, tokenization. It's going to check to see if you're a member of the built-in administrators group, what privileges there may be issues with, any namespace calls that may be causing you problems, and other objects. And off the back of that, what you can do is you can apply a mitigation. And we give this mitigation in two forms. We can either create what's called an SDB file, which you can deploy out into your organization, or we can generate an MSI. If I apply that mitigation and hit apply now, and now if I run the stock viewer application, the stock viewer application launches. No prompt. No saying I need to be part of the administrators group. If I click on the trends, my trends work perfectly. Oh, this is fantastic. This is really good. I'm going to make a load of people loads of money at this moment in time. So now I can even export that mitigation out. I can look to export it out as an MSI and either distribute that using something like SCCM or another tool in your environment and push that out to my client platforms. The other tool that I can use if I don't want to use the Standard User Analyzer is I can use a tool called Compatibility Administrator. And Compatibility Administrator, I can go through and build up this SDB file that contains all of my fixes, all of the problems with this application manually. So if I don't want to use the tool and I just want to create a single SDB file, I can do. So I'm just going to copy my outputs here for this one. I'm going to apply it to my current database. And I'm just going to hit save. So stock viewer. I'm just going to dump it to my desktop. And what you'll see here is I have this SDB file. And that SDB file, again, I can incorporate into some sort of deployment methodology and push that out. So here's my broken client. And all I'm going to do is I'm going to run a command called sdbinst. And I'm going to run it against the SDB file that I created. I'm just going to say run it in a silent mode and deploy that to my client machine. That easy. Now if I go and launch the stock viewer application, launches extremely quick, no check for administrative privileges. If I go to my trends, the trends work perfectly, and my issue and problem that I thought was an app V issue is now resolved with the tool set. So again, really... So the SDB file I would deploy down locally to the base operating system. So the question is if I delete my PKG file for my app V application, do I have to reapply that SDB file? And the answer is no, because essentially I would deploy that SDB file to the base OS, and that wouldn't impact my PKG file at all. So our best practice and our practice from the product team at this moment is to have it outside of your app V package and deploy it to the native Windows operating system. Cool. So I flip back over. Yep. Yep. So it's more that we don't want, from the product team's perspective, we don't want to capture the compatibility fixes. We want that to be intercepted by Windows. Essentially what the AppCompat toolkit is doing, or the SDBs or the MSI is doing, is it's sitting there as a layer between your application and the Windows APIs, and it's intercepting those calls down. And what the product team would prefer is that the App Compact toolkit is run outside of the AppV environment. So again, we can create those mitigation issues for our applications and deploy those mitigating issues out to our general environment to make them work correctly. And we've done this with a large number of applications. I think I've done it with lots of applications like Toad, SAP, a large number of applications to make these work on a later release of an operating system. Well, so what we're trying to do there was two things. So one, we're trying to do the isolation. So the isolation is basically stopping those files that would normally end up getting deployed down to the operating system, essentially essentially having conflicts and potentially writing to the same location. So there's the isolation which the AppV piece is trying to define. The SDB file is essentially, it's a database on every Windows 7 machine. And by default, Windows 7 has a huge database on it out of the box. So if I go into Compatibility Administrator, and if I show you the list of applications, and this may take some time to render, but there's a whole raft of applications it's clicked, there you go. There's a whole raft of these SDB files, or basically these compatibility fixes, that are there out of the box straight away on Windows 7. Oh, God, sorry, yeah, well done. So yeah, this is Compatibility Administrator, and under Applications, you have these whole raft of fixes that are already there out of the box that come out with Windows 7. All we're doing at this moment in time is we're just adding to that list. And we're basically taking your specific application issue that may not be taken into account today and just creating a shim file for distribution out there into your environment. So the next case that we have is the case of the conflicting Java. So Java seems to be a popular one, and it seems to be a popular one that gets deployed. And essentially what happened with the customer is they deployed the latest version of Java to their base operating system. They wanted the latest version of Java there so that they could run all of their standard applications or run Internet Explorer and not have a user click on a secondary shortcut to launch their Java apps. The problem was that when they sequenced their legacy versions of Java, all of a sudden those legacy versions of Java would use the base operating system's version of Java. And that wasn't good to them because they started having application issues and application problems. What we ended up doing is we ended up using Procmon to analyze what was taking place when Java was trying to be executed. And essentially what you see there, and it looks like a whole raft of stuff, but essentially we're browsing down the HKey users software classes CLS ID branch of the user's registry. And what was happening there were certain registry entries that the virtualized version of Java and the local version of Java were merging together. So in the virtualized application, what was happening is it was getting a merged view of the local operating system's registry keys. And because it saw a newer version of Java on the local operating system, it thought, you know what? I'm meant to use this. This is correct. So with this in mind, you have to think about, again, a bit more about the sequencer and about its logic and how it approaches things. So there's this thing called opacity and translucency in the sequencer. And what essentially this means is, should a file that's inside the virtual environment have a merged view of the operating system, or should it override the operating system's view? And there's a real simple method to this madness, and it essentially is this. If the registry or file already existed on the platform, and we just add another file or folders into that existing structure, then we set it to merge. If it didn't exist, then we set it to be blocked. And a good example of that sort of situation or that behavior is with Adobe. Bless you. So here we have Adobe. And if I launch Adobe, and if I go to File, Open, and if I just quickly browse to see Program Files, x86, Common Files, I see a folder in the structure. This is inside my virtual environment of my virtual application for Adobe. And then within that, I have a number of other files inside that folder structure. Now, if I browse to see program files, common files, what do you see different? We see that the Adobe folder that is there on my, inside my Adobe application isn't there on my base platform. Because that Adobe folder was created at the point of sequencing. Now, when we created that folder inside that file structure, it said, there's other files in here with me, so I'm going to set myself to merge. But anything below that folder structure, I'm going to basically override the operating system's view. I'm not going to show this folder structure or anything in a subfolder structure that the operating system may have. So if I go along on my OS, create that Adobe folder structure, and if I start creating lots and lots of files in there, we wouldn't be able to see them because the virtual view is blocking our local view of the platform. So with that in mind, we started to think about this Java issue. And remember, if we have these are our two different views. We have the virtual view and the app data, and then the client operating systems view. And if we want to merge view, we get this sort of merged, truncated view of both the virtual view and the client side view. And we also get this override view that gets taken place if we don't have that folder structure already there. So we started to think about this from the virtualized registry keys from the virtual Java and the non-virtualized registry keys on the base platform. And we came up with this solution. We're getting this current view of a merged view when we're executing Java. But what we actually want to do is we don't want to see this non-virtualized view. Now, when you go ahead and sequence applications, we monitor for anything that gets installed and any changes that take place to the platform. But one of the other things that we monitor for at the point of sequencing is we monitor for deletions. So if you delete a registry key whilst you sequence an application, we capture that deletion and we keep that maintained in the virtual environment. So we thought to ourselves, you know what? Let's export the local registry keys for Java onto our sequencer before we start sequencing. And then when we do start sequencing, let's delete them. That will give us this view. It will give us an override view of those registry keys on the base platform, and because we think that they're deleted already, we won't see them on the base operating system, and the Java in the virtual environment will work correctly. And that's exactly what we did. And this is the output and the results from that activity, that we get the local version of Java using the correct version of Java, and inside the virtual environment, we had our legacy version of Java execute correctly. The next case is a case called the case of the missing short names in dynamic suite composition. And what essentially was happening was that we had an application, we had two applications, Word 2007 and a plugin to Word 2007. And they both sequenced separately. So Office was installed in its own package and the plugin was installed in its own separate environment. And what we wanted to do was we wanted to use DSC to essentially bring this plugin into the Word application. However, we got this lovely little error dialog box appear whenever we tried to launch Word, once we did dynamically sweep the application together. What we ended up doing was we ended up again using Procmon to analyze the information of the crash. And what we saw were a number of core activities, and they're all highlighted up there. We saw a number of reg queries take place, and then we saw another create file query take place to a DLL. This is the analysis that actually we did, and the reg query actually was a query for a specific DLL file on C program files common magic wordco.dll. And when WinWord was trying to execute against that DLL, basically read in that DLL to launch the application, it couldn't find it. Now this one's interesting because with dynamic suite composition, we get the benefits of sweetening two or more virtualized applications together. But the problem with also dynamic suite composition is that we can only have one set of short name tables when we create that virtualized view. And that short name table that we maintain is the primary application's short name table. And we do that so that we can prevent ourselves from having conflicts. Now, as we saw in the earlier slide, when we were trying to query the registry, we were querying for a short name to that DLL. And because we didn't have the short names table for that DLL, we were basically failing to execute that DLL, and therefore Word was failing to launch correctly. So what we ended up doing was we ended up updating the specific registry key for that application to a long name or a long file path for that particular DLL, and the application executed correctly thereafter. So the last case off is the case of the missing environments in Dynamic Suite Composition. Now, Dynamic Suite Composition is a really handy tool. It's really super powerful as well. It gives you basically the ability to suite in applications on demand that you may require access to. I use it all the time in Word and in my Office suites. Whenever I want a Microsoft add-in, I just add that dynamically into my virtualized version of Word 2010. So essentially what the customer had was the customer had a primary application and they had a secondary application which worked absolutely perfectly on their own in their own isolated environment. But when they tried to launch them together at the same time, they produced inaccurate results. Now, they use this tool, and this is the Dynamic Suite Composition tool. It basically has 3 key areas, the top left, bottom left, top right. The top right, you specify your primary application. The bottom left, you specify your secondary application, and you just add them together and hit save, and there you go. You have 2 virtualized applications, or a virtualized application that can see another virtualized application. When they did this, it basically injects what we call a dependencies into the primary application's OSD file, so that when it launches, it triggers off this secondary application to launch in the same namespace. Now, with that in mind, we can see certain attributes in this OSD file. We can see that it's got the secondary application's code base, and we can also see that it's also got a number of environment variables. But this application wasn't launching correctly at all. When we did a bit more of a look on the client machine, we saw this. And what we noticed is that in the primary application's original OSD file, it has a number of environment variables set there. But also what we noticed was that in the secondary application's OSD files, it also had a number of environment variables set inside that. So that when this secondary application launches in its own isolated environment, it invokes those environment variables. But when it was suited together, it wasn't invoking those environment variables. So we essentially brought all of those environment variables together into the suited primary OSD file, and therefore the application was able to execute correctly because it knew about its environments that it wanted to launch against. Now, we see this a lot with Oracle applications, where a customer has Oracle sequence, and they want Oracle to be dynamically suited into multiple other applications that they create in AppV. Now, the big thing about that is that it tends to have the Oracle application, that's generally the secondary app, tends to have a TNSNames.aura file associated with it, and when they suite it in, it's normally set in an environment variable, and that primary application doesn't have that environment variable set, and therefore we see lots of failures in that scenario. So by doing this and putting in those environment variables, you can have that be solved and those issues be resolved for you. So hopefully that was quite interesting for you. Lots of different issues, lots of different cases that hopefully you could take the troubleshooting steps towards and fixing your environment for your customers. Thank you very much for your time. You've been a great audience. Enjoy the party tonight. Please try and abuse the Microsoft hospitality and drinking as much booze as possible. Thank you very much and have a great evening. Me in, so feel free to go for it.